Hello, 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 out there in Streamland. How's my mic sound? We're just getting set up, and we will be with you very shortly. Hey, everybody. We're just getting set up. We are going to be starting in about 18 minutes. I'm just making sure that the stream is working and everything, so just hang out. If you want to grab the assets for the training, I will put them in our channel on Unity Connect, where you can grab them. I am just getting that set up right now, so give me 1 second. Oh, I hear myself looping through. There we go. All right. So that sounds good. Now, hey, everybody. I see we've got Mike Koch from Cybernetic Walrus in the chat. Welcome. We've got a bunch of people. Mike Geig, and we got a lot of mics. Mike. That's good. We need more mics, actually. So we've got some now. All right. I just need to get this stream embedded in our Connect page. Let's see here. Nope. Hey, wow, we got Tokyo logged in at 4:43 a.m. That's exciting. I'm just getting a little... That is early, man. Wow. Thank you for joining us, Koichi from Tokyo. Part of the Unity staff, I think fairly recently joined, so welcome aboard. The ship that you're seeing is from Antigraviator by Cybernetic Walrus, and I'll give you some links to check out. You can check out antigraviator.com for sure. Is a great place to learn more about that, and you can also wishlist the game on Steam. It is going to be coming out in the next few months. I'm just having a funny old time getting the stream added to the Connect page, which worked great last week. But of course, now that there are many people hoping to see it, it's giving me an issue. So let's find out what that issue is. this is the page. It's live on YouTube. And let's try this one. That worked. Okay, good. Okay. So you should now be seeing, if you are on the Unity Connect page, you should be seeing the stream. Give me a signal in the chat to let me know that you can see it and that you can hear my mic okay, please. We're going to be starting in about 14 minutes. So please make yourselves comfortable. Yay, it's on. Okay, great. Oleg, thank you for the sign. Thank you. So how many people do we have here? Wow, 328 people already. That is exciting. Let's see. Oh, that's total. 66 members online. Okay, I'm still learning to use Connect myself. So we get 66 people. That feels more like it. Okay. Good. Cool. Okay, folks see it. Colombia is in the house. Welcome, welcome. We've got folks from Japan and from Colombia. I am broadcasting to you guys from Berlin, Germany. So it's nighttime here. It is almost 9 p.m. And we've got Mike Geig in the chat. He is one of the guys that you're going to be seeing in the videos that we're going to be watching. So we're doing something a little bit different from our traditional live training format. And what that is that we're going to be broadcasting some videos that we have recorded before and hanging out in the chat and talking about them. And then we're going to take some short breaks with me on the microphone to kind of host and talk through some of the stuff that we've discussed in the chat. So Mike and I will be here to answer your questions while the video is rolling, which is a cool advantage of this format. So this was kind of inspired by Twitch plays Bob Ross. Everybody getting together to watch Bob Ross videos on the stream. I thought that was kind of fun. And just this idea of like collective video watching seemed like a lot of fun. And I thought it would be an interesting thing to try with something like Training Day. So this is about almost 4.5 hours of content. So we're going to watch about 1 hour and 15 minutes of it tonight. And then tomorrow we're going to watch another 1 hour and 15 or so. And then on Thursday night, we'll watch the final batch of videos. So we're going to be watching this together, discussing. You can grab the assets and follow along. I will link the assets in the chat. The assets can be grabbed right here. Let me drop those in. There you go. So you can grab those from the central moderated chat. Wow, we've got India in the house, Istanbul, Iceland, Peru, Tunisia, California, Thuringia, Germany. Hello, hello. Philip Novak, Australia. Man, we are really covering the world tonight. That is absolutely amazing. I honestly find it hard to believe that we have all these people from around the world together with us tonight. That is deeply awesome. Also, I know a lot of you guys from Twitch, where we previously used to broadcast, but we're all under different names here on Connect, right? So please, if you are a Twitch regular follower of the stream, put your Twitch user ID in the chat so I can recognize you guys, just for fun. And yes, okay. Hello, we got Mark from the Connect team. It's working, Mark. It's working. I had like a little moment of panic there because I thought the stream wasn't working. There's a little funny stuff with getting a YouTube URL into Connect. You need a certain URL. And I sent Mark a panicked Slack message being like, it's not working, it's not working. But it is working. So we're fine. We're fine, Mark. I don't know what time it is there in California. And I know that you're out sick, so thank you for taking a moment to check on me. Oh, man. India, Pakistan, Delaware, the UK, Germany. A bunch of people from Germany. Hallo, wie geht's? Deutschland. Indonesia, Canada. I think we are truly covering the world. I will advise you via chat to refresh the page if you don't see video, please. And I put up a little graphic over on Twitch for the folks who are showing up in the old place. So hopefully they can find their way over there. If anybody has the Twitch chat open and you see somebody wandering around in there looking lost, please give them a signal to join us over here on our new home for online evangelism. Yeah, we got people. We have got people. Let's see who else we have. Oh, Gideon, what up? Good to see you again. Gideon 303 in the house. Awesome. Portugal, Switzerland, Poland, Russia, Italy, Israel, Norway, hello, Istanbul, Spain, Colombia, Wales, amazing, Taiwan, wow, what time is it in Taiwan? It's probably also like 4 in the morning. Good golly, Miss Molly. Thank you, we appreciate your efforts as well, showing up, Abdullah, appreciate you. I think it's amazing that we can get people together like this to learn about video games. Super, super fun. Yeah. Let's see. All right, we got 8 minutes. We're going to start in 8 minutes. We've got the link to the assets in the chat. So I'll put this in the central chat in case anybody else shows up. Actually, I already did. The videos will be posted immediately after the event. So there will actually be an automatic archive of this, the playback with the questions and answers. But I've also scheduled the videos on YouTube, since they're already finished and edited, to go live immediately. So, yeah, so we're on track for that. So if you guys miss them or you need to leave, or for anybody who shows up tomorrow in the future, if you're listening to me from the future, you can catch the videos and catch up and join us tomorrow night. And I would love to see you then as well. So we'll be here at the same time tomorrow night and on Thursday night, which is going to be super fun, all of us together. Mike Geig is here. We've got a couple other folks from Unity Technologies in the chat as well, which is super nice. And yeah, it's going to be a blast. So we're going to go live with the content in about 7 minutes. We're covering about 75 minutes of actual content. I'm probably going to do the on-microphone breaks between, a little on the shorter side, just so we can get through the content and not be here until all the way in the middle of the night. But the benefit of this format is that Mike and I will be here in the chat, chatting away, typing away with you as you have questions. So that should be super fun. We're not going to learn COBOL. No, we're not going to learn BASIC either, or assembly, or any other ancient dinosaur languages. We are going to be learning making video games using the Unity game engine, or real-time engine, as we like to say now, because people are doing stuff besides games also. Brazil is in the house. Hello. Welcome. Malta is in the house. Amazing. Truly amazing. Let me look at our lost lambs over at Twitch and make sure they can find us okay. All right. Cool. I'm just pointing out to one particularly lost person over in the Twitch chat that he can join us over here. Yes, and we've got Mike Koch. I hope I'm pronouncing your name correctly. He's from Belgium. I guess that's a Flemish name. I'm going to say Coke. And he is joining us from Cybernetic Walrus. So Cybernetic Walrus are the developers of Antigraviator, which is the game which has very graciously provided us with the assets that we used for this project. So we're not actually building Antigraviator, right? That's their game. We're building a little demo that uses some of their assets. But if you are inspired by what you see, I highly encourage you to check out Antigraviator at antigraviator.com and also to wishlist the game on Steam. And actually, I have a link to give you for that I will post in the chat. Let me grab it real quick. Antigraviator. It is in my email. And I will grab it. Let's see, where is it? Shoot, boop. Here we go. I'll put this in the main chat so everybody can find it. The assets we're using are from the amazing Made with Unity game. Unity, I should spell the name of Unity correctly. Game Antigraviator. And you can wishlist Antigraviator now on Steam, and there's a link for that. And if you're a console gamer, you can subscribe to their newsletter on the official website to get notifications about further news. And so, yeah, encourage you to check them out. They've been super nice in sharing their content with us to use for training, so huge round of applause for them. And if you have questions, Cook, okay, excuse me, Mike Cook. All right, that's easy. And so, yeah, Mike Cook from Cybernetic Walrus is here with us. And if you have questions about Antigraviator the game, please feel free to ask him and he'll be able to help you. Or about the development process of the game in Unity, or any of that. Yes, thank you. Okay, we've got it there in the chat. And, okay, I'm just reading the chat. We're going to start in 2 minutes. You should be seeing the starting soon screen. Okay. Nice, yep. And don't forget, yeah, the Mike Geig that we have here with us in the chat, for those of our longtime live training fans, is the Mike Geig who, of many, many years of live training fame, and you can say thank you to him for that, because as some people in the chat are doing, he delivered a lot of awesome live training through our channel, along with myself and Adam Buckner, who have all participated in that over the years. And he is here, and you are going to be learning more from Mike tonight, because he is one of the lead trainers in this video, in this presentation. So that is going to be super fun. Let's see, is Steak Pinball here? Yay, Steak Pinball is here, yep. Oboe Shape was here last week. Maybe he'll turn, I think actually he said maybe he wasn't going to be able to come this week, but yeah, love to see the live training regulars. For folks asking, yes, this will all be available on YouTube. I'm going to record both the live presentation, and I am going to present the edited versions of this as well. That's not what we're doing. Okay, so let us begin. So what I'm going to do is I'm just going to take you directly into the training. We're going to see a little bit of introduction from our evangelism team, and then we're going to take a little break for some questions before we go further. And so without further ado, I give you Training Day Unite Austin.
So a warm welcome to the training day. I'm super excited to learn myself. I'm actually Kara Kallenwart. I work at Unity Technologies within the Evangelism team on helping spreading the knowledge of new features. Unity is about democratization. It's giving access to those features to small and large studios. And that's why we worked with the game studio who created Antigraviator, a Cybernetic Walrus, to really define this workshop. And I'm very excited to introduce them. They are here. We invited more than 50% of the game studio to come to the stage.
Well, good morning, everybody. I hope you guys are as excited as I am to be here. So my name is Mike Cook, and I'm the managing director of this big studio, and I'm also one of the programmers on the game.
Hello, my name is Szabolcs, and I'm a technical/environment artist on the game.
You can probably hear Mike and I have a similar accent. We're both from Belgium. I'm from a better town than his. So let's see in action, actually, what we actually will be building. So that's why we have our head of global content, Mike Geig here, who will be showing how we're going to have fun today.
We'll do introductions in a second, but I want to kind of talk about what we're going to be showing you, what we're going to be building today. We are going to be building this game here, which represents a slice of this game. And we'll see here, I should have gone full screen, but there we go. So we're going to look at timeline, we're going to look at Cinemachine, we're going to build some opening cinematics. We are going to look at adding post-processing, particles, doing a lot of cool stuff, some custom physics through code, some Text Mesh Pro, and we're going to build a racing game that looks pretty slick and is very easy to crash into stuff. And so we're going to have some fun with that, but I wanted to start off sort of by talking about, okay, this is what it is that we're going to be building today, so we have a common goal in mind, so we know what we're working towards, which is very important. So some pretty cool stuff. Who are we? My name is Mike Geig. I do content for evangelism. I don't know what my title is. And then we have our awesome Andy Touch.
I'm like Mike, but English.
Yeah, there you go. That's pretty much the only distinguishing factor between us. Fantastic. Okay, so let's get started. So we've broken today up into several learning cycles, all right? And so what these learning cycles are is these are kind of modular pieces of learning, things grouped together to assist in understanding, to kind of see how we're working towards this common goal.
Whoop. That's not what I want. Let me go to this, Q&A. Okay, haha, I'm still here. Okay, so that is clip one. We had a couple of questions from the chat about how to get a bigger view. And my best answer for that right now, I'm aware that there's a couple of little UI issues with Connect in terms of the window being a little bit small, and that is something that we are actively working on. What I recommend at this moment is to float your cursor over the YouTube window and pop it out as a separate window. As I said in the chat, yeah. Folks are just, the chat is it's just seeing my, woohoo, it's a party, guys. That's why this is live. That's what makes it fun, right? Is the chaos and failure. Okay, before we all get too confused, hopefully that's the only question we have right now is about the windows and stuff. So let's dive right into clip two.
Cycle one, getting started. So I have my project open here in Unity. I am using Unity 27.1.1F1, which is super easy to remember. It rolls right off the tongue. And I have this scene open that I was just showing you guys, talking about here, as far as the completed version of the game goes. So I'm going to do two things real quick, just in case I were to have like a peculiar editor setup, because we can do all sorts of wacky stuff with our editor. I want to make sure we're all seeing the same thing for those of you who are fairly new to Unity. And so I'm just going to go to the upper right-hand corner, and I'm just going to click where it says the layout or default. I'm just going to click default, That's just going to bring me to the default layout, so we're all seeing the exact same thing, and that's all relatively well and good. And then I'm going to go ahead and create a new scene, and I'm going to do that by going to File and then New Scene. And this is just going to give me a nice new blank slate. I don't want to save anything. And so here we go. We have a new, just sort of open, generic scene here. All right. And so now that I have this, a couple things I want to talk about in the project. We have down here what's called the project window. And the project window is going to have a whole bunch of these assets being these files on the hard drive. And we're going to be using stuff through these folders, all right? One of the folders I really want to point out is this scenes folder, which is going to have all of our levels, all of our scenes. And inside here is a completed folder. And so if at any point you get lost, you can just jump to whichever scene we're on to get caught up or whatever, if that's the case. But I do encourage you to follow along in your own scene. We also have some prefabs and add-ons and all these other words that I'm going to talk about that you may or may not know or understand or make sense. We are going to explain them. But one of the other things that was provided with the files for today was a reference sheet. So if you are brand new to Unity, there's a reference sheet in those files we gave out that's got your hotkeys, how to navigate around, what some of these terms mean, like what is an asset, what is a scene, what is a component, and all these things. So I've got my project, I've got a new scene, and so the first thing I'm going to do is I'm actually going to disable light baking, which might seem a little weird as the very first thing that we're going to do, but the fact of the matter is this is a racing game, and we're going to end up capping out, I believe the terminal velocity in this game is 100 meters per second, which is roughly around 240 miles per hour. Really, really, really fast. We're not going to really benefit from baked light, bounce lighting, all these things. We're going to be going really, really fast. And so, you know, since we don't know what kind of machines everyone has here, we don't want them to be churning for hours trying to bake a light map for something that's really not going to make that much of a difference. So I'm going to go up to my window at the top here, and then I'm going to go down to lighting, and then I'm going to go to my settings, which opens up this new panel, which can be dragged around here. And I'm going to grab the tab of that, and I'm just going to dock it to the side, which is where I like to generally place that. And then I'm going to go to the very bottom of this window, and I'm just going to uncheck Auto Generate, which is going to say, you know what, I don't need lighting or baked lighting in this scene. That's fine. And I'm just going to turn that off. Then I'm going to go back to my project window down here, and I have a prefabs folder, which I'm going to click on. And I'll talk about what a prefab is in a moment. And then I have a track folder, and in here I have this thing called track. And this is going to be our race track. And I can drag this into my scene view, this big window here in the middle, and you can see it's moving around as I'm dragging. But since I want a very specific placement of this, I'm not going to drag it into my scene view. I'm going to drag it instead to this window on the left called my hierarchy. And you'll see here in my hierarchy, it is now listed, and you can see I also have a main camera and a directional light. So this track is actually just a combination of a few different elements that have been put together. And again, we'll talk about how that happened here shortly. But we just wanted to start with something that would technically be playable. You could already drive around on this track if you really wanted to. The stuff that's inside here are just some colliders that makes the car not go through the ground or the walls. And then just some posts and other things that are just sort of graphical embellishments. So now that I have this, I've got a scene, I've turned off lighting, and I've got this track, I'm just going to save my scene. And I'm going to do that by coming up to File and then Save Scene, or Control-S or Command-S. And I'll save this into my Scenes folder. Where I save this, I'm saving it into my Scenes folder purely for organization. The folder doesn't matter. The name of the folder doesn't matter. The name of the scene doesn't matter. I could name this anything I want. I'm gonna name my scene Rocket, because it doesn't matter, right? Any name I want to give it is fine, and there we go, Scene Rocket, blasting off at the speed of light.
Okay, so let's try this again. Let's see if we can avoid going into sceneception. I think it's working. This, as long as you guys are all seeing PowerPoint as well. So I'm just going to put the steps up on the screen. So for those of you guys who are following along, and I'm just responding in the chat. And so if you guys have questions, further questions in the chat, we had a question about will this be available offline? The answer is yes, it will. It will be immediately posted on YouTube at 10:30 p.m. As we get to the end, and then also there will be an archive of this with all the talking and all of my terrible mistakes as well, which we know and love. So if you want to catch up on the steps so far are that you're going to open the project and create a new scene, where you're going to open the lighting window and basically uncheck real-time global illumination, uncheck bake global illumination, uncheck auto generate, and then in the project window, you're going to locate the folder, assets, prefabs, track, drag the track prefab into the hierarchy, right, importantly, so it lands at origin, and then you're going to save the scene, right? So just doing some basic, getting some basic level geometry in, and now we are going to continue with cycle 2. Okay, we have one, before we continue, I see another question coming up. How do we open the project? The best way to do it is to go to open an instance of the Unity editor and then select Open Project, as Mike is helpfully answering in the chat. That will preserve all the project settings and everything. Some people are used to just double-clicking a scene file, but that doesn't always open it correctly. And actually, we'll talk about that a little later in the videos. There's a few people who got tripped up by that. So make sure you open the Unity editor, go to File, Open Project, and navigate to the folder that has assets, project settings, etc., and then just click Open Project. We have a question about the models in the game. The models are not built in Unity 3D. So Unity is not a 3D model creation tool. You can make cubes and primitives and so on, and there's some tools on the asset store like Pro Builder that allow you to do some modeling in the Unity editor. But generally speaking, people will use a package like Max or Maya, and you can actually ask Mike Cook, one of the developers in the game, who is here in the chat, what software they use to create the game. Because I don't know, but I'm sure he does. So what we're going to do is we're going to move on to cycle 2, setting up the environment.
All right, so we are going to set up the environment. So the first thing I want to mention is that, I have this track here and I can see the track and great, but if I want to look at the track some other way, I need to be able to move around in my scene. And so if you're new to Unity, this can sometimes be maybe a little confusing, which is why we've got that reference card that has, the hotkeys and stuff. But what I'm going to do is I'm just going to talk about the version that I prefer, which I know it's a polarizing thing. Some people prefer it this way, some people don't. But what I like to do is with my mouse over the scene window, I like to hold down the right mouse button, which puts me in fly-through mode, which allows me just to move my mouse and look around. And also, while holding down the right mouse button, I can use WASD to basically just walk around as if I was playing a first-person game on a computer.
You can do this on trackpad as well, but with a mouse, it's definitely
a lot easier with a mouse.
Yeah.
But again, we have this cheat sheet here. So there's also Alt middle click to or move, Alt left click to orbit, zoom, select, that sort of stuff. So there are many different styles of navigating around in the scene view. I just like to point out the fly-through mode because that's the way I like to move around. But everyone has their own preferences. If at any point I'm wandering around the scene and I'm just totally lost, like I don't know where I am, I can always click on any object in my hierarchy, move my mouse over the scene view and hit the F key, which will frame select it, or I can just double click on something in the hierarchy to find it, and then that just moves it to the middle of my screen. So that's just some FYI stuff. That's how I'm moving around. So now I'm going to begin building up the rest of my scene. So I talked about this track being something called a prefab. Stands for basically a prefabricated object, right? It's some series of game objects, some game pieces that I've already set up and put together. Now, since the purpose of today is learning a lot of new features, we're going to shortcut a lot of sort of basic minimal steps with prefabs, just to cut some time out of the day. And so I'm going to go down to my project view, and then I'm going to go to my prefabs folder, bless you, and I'm going to go to my environment folder, and then I have a whole bunch of environment prefabs. And I can see some of them have like some graphics, some of them are just blue, but these are just several prefabs I have in my project. And I want to look for my sand floor, which is basically just a piece of terrain. I can look here in my inspector window and say, just a piece of terrain. The only reason it's a prefab is because I just wanted it to have some starting position in my scene that was known. And again, I could just drag this into my scene view, but I don't really know where that's going to go. So instead, I'm going to drag it into my hierarchy, and it's just going to place it where the prefab is meant to be placed. And I've just got some terrain. This is just Unity's terrain. I could, if I really wanted to, just click on my terrain tools and start sculpting terrain if I really want. I'm not going to right now, but we certainly could. It's just a piece of terrain that's going to give us sort of this level here. Now, it's kind of basic, so we do want to do some decoration. And so I could, if I didn't want to use a prefab, and if you wanted to see how these things sort of came together, I could go down to my project view, and I have this models folder. And in here, I have several types of models, rocks and arrow signs and posts and stuff, and I could just drag a rock into my scene and place it. Then I could use the tools that Unity has in the upper left-hand corner, the hand tool, translate tool, rotate tool, scale tool, and rect tool, or hotkeys Q, W, E, R, and T, and I could use that to manipulate this object. So for instance, if I grab my translate tool, I could move the rock, say, into the ground, and then my rotate tool, and maybe do something like that, and then my scale tool to maybe just shrink it down a little bit, and then drag in another piece of ground, and so on and so forth. I just drag in a bush there, and and I could do this and just begin building a scene. Maybe I just want a frame out here, whatever, right? It's just it's as easy as just drag and drop, right? And just move stuff around and align it and whatever I want to do. Now, I don't want to walk through this whole day of dragging in 100 of these little rocks, right? Let alone every other thing we need in this scene. So we just created a prefab that has a lot of this stuff already in here and set up. So I'm going to go to my prefabs folder, to my environment folder, and I have rocks. And I'm just going to drag that into my hierarchy view, and now I have rocks. And trust me, you did not want to hand place all of these rocks today. All right, that would have taken way too long. But if something is just annoying you, like this rock, you just hate this rock, well, just click it, right? You can just move it. It's just like we were doing the other stuff, just get rid of it. It doesn't really matter. I'm not actually going to do that. But if for some reason you just despise that rock, then that's fine. That is entirely up to you. I'll move it back. Okay, so nothing special here. These were just a whole bunch of rocks that were already placed for you, so you don't have to sit here and do all that. Now I'm going to continue on here. I've got rocks. Now I'm going to drag in some skyline. So if I'm racing around, there are parts of the track that I can be on where it just kind of looks a little fake, right? Like, okay, I can see this mesa here, but there's just nothing behind it. Like the world is perfectly flat beyond this little race course, like even right over here. And so I have this skyline, which I'm going to, again, drag into my hierarchy. And what this is it's a large cylinder that just has a texture on it that looks like some very distant mountains, right? And so as I'm racing around, all I'm seeing is, oh, look, there's some mountains in the distance. It doesn't matter to me that it's a flat texture. I can't tell. It's too far away. But it gives me that sense of depth in my world. I also have some pipes, which I'm going to drag in here that just add a little bit of sci-fi flair to our scene. The pipes don't seem to go anywhere. They just make one giant circle, but whatever, it's sci-fi. So we got some pipes. I've got some flags, all right, which I was saying yesterday I really should have added 3 more of them so we could call them 6 flags, but we didn't. And I feel like that's a lost opportunity. And then finally, drag in some bushes there. And so now we've got this level with a whole bunch of stuff kind of built into it. And this is great. This looks pretty good. We're going to continue adding more and more to this. But if I wanted to, say, move all of this, or create another scene and have this level in it again, or load this scene at runtime, or something like that, it would be very difficult right now because I've it in all these different pieces that are not associated. So what I'm going to do is I'm actually going to turn this entire environment into a new prefab, which is going to show us, okay, this is how these prefabs were built to begin with, and also allow me to reuse this if need be. And so what I'm going to do is I'm going to go again to my hierarchy window here, and I'm just going to click the create dropdown. I could also just right click. I'm going to click the create dropdown. I'm going to create an empty game object. And I'll just name this environment. The name of it does not matter, but I'm just going to name it environment because that seems to make sense. And it's always a good idea to just take our objects, like containers, and just put them at 0, 0, 0 at the world origin. It's just good. It makes it easier if you're bringing them in other projects and stuff. And so now what I want to do is I want to nest, all right, that's the term nest, all of these environment pieces onto this game object I just made. And I'm going to do that simply. I'm just going to click on my sand floor and shift click on bushes. I'm just going to highlight all of these, and I'm just going to drag them onto environment. So now they become children objects of environment, right? So they're all just contained in there. It is great because it allows them to be moved with just this one parent object. It also allows us to organize our hierarchy a little bit so we don't just have thousands of objects in the hierarchy. And so now, if I want to turn this into a prefab, I'm just going to click and drag this environment game object down into my project folder. I'm going to drag it into my prefabs environment folder, but again, the folder doesn't matter. The name of the folder doesn't matter. I just need to drag it down here and drop it. And then there it is. Environment is a prefab. And what's cool about that is if I, in a fit of rage, say, oh, I hate my environment, go away, and then I think, you know what, environment isn't so bad, now I feel bad, I can just drag it back in and there it is again, right? And I haven't lost anything because it is the environment. And furthermore, if I were to just start just deleting stuff out of it and I think, oh no, what have I done? I can go back to environment now that it's a prefab and I can say revert. And it's just going to undo all that stuff I just did in a fit of rage. So there we go.
It's probably worth mentioning as well that anytime you drag a game object back into the asset folder in your project window, then it will turn into a prefab. It doesn't have to be in the prefabs folder. It's just anytime you bring that game object back down into the assets folder, it will turn it into a prefab.
Okay, so, I just realized this is really small, or really big rather. Let's see if I can fix it. Can I fix it while it's live? This is sketchy. Okay, watch this, guys. Is it gonna work? Yes, it worked. No, almost. Let's do it again. I moved. The reason we had inception is because I had one thing on the other monitor and I moved it to my larger monitor and now it doesn't fit. Okay, there we go. All right, solving hard problems. So, cycle 2, we're setting up the environment. So in the project window, you're gonna locate the assets prefabs environment folder, drag in the sand floor, rocks, bushes, skyline, flags, and pipes prefabs to set up the level, right? And remember, we're dragging into the hierarchy, and that is going to place the object at the position that the prefab was last at. I misspoke earlier and said origin. What I meant was original position. Origin being 0, 0, 0. Somebody in the chat helpfully corrected me. Thank you for that. And then we're going to create an empty game object in the hierarchy and name it environment. We're going to drag all the added prefabs onto it to make them children. And we're going to turn that into a prefab by dragging it from the hierarchy into the project window. So for those of you guys following along, those are the steps. Let's just catch up quickly with the chat. Mike Cook answers that a PS4 release for Antigraviator, the game which we're using assets from, is coming, and the date is going to be announced later. Right now, you can wishlist the game on Steam, or you can join the newsletter at antigraviator.com to find out all the latest. For those following along in the chat, you can download the project files. They're in the middle moderated chat at ole.unity.com, Hover Racer Live, and I'll post them in the main chat again. Whoop. And, okay, let's catch up. Thank you for joining us. Okay, there's a question. The project is still downloading. Yeah, we tried to do a thing where we emailed out links to the project in advance. Let me know what you thought about that. Was that helpful? I know sometimes people don't want to sign up via email for things, but let me know what you thought of that, because I thought that was kind of cool, so you could get it early, download the stuff early, but you tell me what you think. All right. Good. Some folks asking how the terrain was created. So the main mesh is a Unity terrain, and then the rocks and tracks are static meshes. And let's see. Mike Cook answers that they are using triplanar mapping. I didn't see what that was, what the question was, but that is the answer. Ooh, the chat is moving fast. We've got 278 people. I'm happy that I've got Mike and Mike here with me. Let's see. Jason Bartlett asks, about how many people and how long did it take to make all those tracks, rocks, pipes, etc. prefabs? The team is 4 people total, but Mike Cook can answer how long did it take. Oh, nice. Davide loved the email sign up. Well, we love you too, buddy. Thank you. Glad to hear that folks liked it. Yeah, the email thing was a little bit of an experiment. That's kind of why I'm asking for feedback. I'm looking to see if we can do that integrated in Connect, because we're trying to do more stuff via Connect now. Like maybe when you register for the event, you would get automatically emailed, because obviously with your Unity account, we have an email on file. That might be an option. Tell me what you think. The game's been in development for 2 years, says Mike Cook. That's pretty impressive, honestly. 4 guys, 2 years, and this is what they made. Wow. I need to step my game up. And, okay, cool. Some folks talking about okay, so I'm not going to spend too much time chattering away here. Let's dive right into the next cycle. We just looked at setting up the environment, and we're going to move on to cycle 3, light and reflections.
So we are now going to move on to the next learning cycle here, which is improving light and reflections. If your scene was dark, do not panic. So check this out. My scene is lit up right now, all right? Some of you aren't seeing that. You're seeing something dark. What you're seeing is if I were to, say, take the scene right now that I'm in and just reload it, dark. So what happened here? So when you first created this scene, light baking was on. So it baked some amount of lighting data, that directional light with the skybox, and that was baked in. And then you turned it off, but that information was still there, just stored in memory while you had this scene open. So your scene was still lit up as if you had that lighting. Now, if you're one of the people out there who maybe closed the scene and reopened it, everything was dark. Where'd my lighting go? Right? Well, it didn't save it because you said you didn't want it. That's completely fine. We're about to fix the scene for everyone so that it looks right all the time without all that stuff, right? So if you see this dark scene, don't freak out. All you did was just reloaded the scene where other people may not have, and you saw this dark area here. Okay. So what I'm gonna do, first and foremost, is I wanna change the sky. So we have this default procedural skybox, and it looks okay, but it's maybe a little bland here. And so I'm going to change this. And you'll also notice there's a sun in the sky, which is cool. It tracks the directional light, and I'll talk a little bit more about that in a moment here. So what I'm gonna do is I'm just gonna look up at the sky, all right? And I'm gonna go down in my project view to the skyboxes folder, and I have this desert sky. And what this is it is a skybox procedural, just with some different settings on it. So you've got some sun size and some atmospheric stuff and some color stuff. And I'm gonna drag this into my sky. Now it's worth noting that if I try to drag it down here, it's not working. And the reason is that I'm actually still on that skyline cylinder. I need to go above the skyline cylinder. I'll know when I'm there because my sky will get super bright. And I'll just let go. And then there it is. So now we have this super, super bright sky. That may seem overly bright, but trust me, we're gonna add some stuff with post-processing and color correction and all this stuff that's gonna make it look really cool. So we've got this really bright sky there. And so now what I'm gonna do is I'm gonna go back to this lighting panel, and I will see here at the top where it says skybox material, there's this new desert sky. It doesn't say that procedural anymore, it says desert sky. I could set the sun source to be my directional light, but it automatically keys off to the main directional light of my scene, so I don't need to do that. And so now, for my environment lighting, right now the source is skybox, and it's causing some stuff to be fairly dark, right? So we can see that, our shadows are very, very dark because we have no bounce lighting or directional lighting or anything like that, because we're not baking any of this stuff. And so what I'm gonna do is I'm gonna change this environment lighting from skybox, and I'm gonna go to color. And now it's giving me this fairly dark ambient color, and I can choose kind of whatever color I want. I generally just do something brighter. It doesn't really matter what, it doesn't really matter what hue. I go bluish so it looks more realistic, but you can make it, you can do whatever you want with this color, really, it's your scene there. But I have a color that I tend to just use as my reference, right? And I'll put this up on the slides here. This is just the color I use, but you don't have to use this color. That's just, if you happen to want the exact same scene as me, you can check out that color. And so what that does is that evens out the lighting in my scene quite a bit. And so now, if I look down here, I'm just having this universal ambient light applied, so even in the darker areas, there is some light. And that's great. I don't need to worry about bounce lighting and stuff like that because I'm not really gonna notice super accurate bounce lighting because I'm going really fast anyway. And so there we go. So I'm just setting up that lighting. So now I'm gonna click back to my inspector here and I'm gonna play around with my directional light. So there's my directional light. It's just in here. In here is the default of a new scene, right? And as I mentioned before, the light in my scene, of the skybox, the sun, automatically keys off of that directional light. So if I rotate it downward, I can do cool stuff like that, right? So I can do this whole little Lion King, like, right? at this point, I can rotate this light however I really want. It doesn't really matter. I just choose something that I find aesthetically pleasing, right? It doesn't really matter how I rotate my light or whatever. I have a rotation that I like, so I'm going to dial this in. But again, it's cosmetics. It's whatever you kind of like. So I like a rotation of 134, a negative 102, and then negative 241. People asked me yesterday why those numbers specifically. Why not pick more rounded numbers? And I said, I like those numbers. And so those are the numbers I dial in there. The other thing, I just like it gives these nice little shadows right here on the ground, which kind of tells us which way we're going, and it just sort of I don't know, I like it. And then if I look down here towards like the sand parts here, they can be a bit yellow because my sunlight is fairly yellow, and I might lose a little detail there or whatever. And again, this is purely cosmetic. You don't have to do it, but I like to just click on the light of my directional light and just kind of orange it up a little bit or just darken it a little bit. And again, I just have a value that I tend to use, and I feel that it just sort of brings out more of the little flecks in the sand and some other things. Purely cosmetic, but it's something that I like to do. Now, if I look at this pipe, now the pipe is going to look different for me than it will for anyone who never reopened their scene, right? So for a lot of you, the pipe is going to be very dark like this. For a lot of you, the pipe is going to be silver and be reflective and stuff like that. So for those of you who never reopened your scene, where your scene stayed light the whole time, what you're seeing is actually the reflections of the old skybox, because that was baked in when you opened or when you created the scene and baked was turned on. So it's reflecting the scene as it was, not as it is. I've reopened my scene, so I don't have that data, so it's not reflecting anything. And so what I want to do is I want to create some information about reflection. And to do that, I'm going to create a reflection probe. So I'm going to go to my hierarchy, I'm going to click create, then I'm going to go to lights, and I'm going to say reflection probe. And that is going to put a reflection probe in my scene, which is going to have some data in it. And I like to position this reflection probe pretty much right in the middle of my scene. So if I were to, like, say, zoom out like this, I could just move it around, or I could just type in the numbers here. I think it's something like 400 and then like 80 and something, whatever. But I just need to get it close, right? I just need to get it close to the center of my track, as I can see here. And now if I go back to this reflection probe, I'll just kind of zoom back down on it here. What I'm going to see here is that it's not really updating anything in my scene, and its bounding box, the things it's able to see, are rather small. Now that might be hard to see on the projector, but there is a little yellow cube there. Maybe that's a little bit easier to see. That's the bounding box of that probe. That's what it can see. And so I'm going to fix a couple things here. So in the inspector for my reflection probe component, under type, I don't want this to be baked. I'm not trying to bake stuff. I don't want to click on here. I'm not a baker. I want to set this to real time. And what this is going to do is it's not going to run all the time. Don't think real time bad. This is awful. It's by default set to real time on awake. It's going to bake one time when it first moves, or when I first start my scene, or when I first run my game, bake one time, and that will have the most up-to-date relevant reflection data. So if I were to change something big in my scene, it would reflect that. It would have that. I wouldn't have to rebake anything manually or whatever. I'm not going to set this up to like every frame. This would be bad, right? This is super not efficient. I'm just going to set this to once on awake. Now, for the box size, it's too small, right? And so what I'm going to do is I'm going to set this to something like 1700 by like 500 by 1200. So this bounding box covers my entire level, right? So now, it's probably hard to see on the projector, but I have this giant bounding box around my entire level. And so now, if I look at these pipes, all right, I can see reflections in them, and the reflections, while they are stretched, because that's what the pipes are supposed to look like, they are actually reflecting what is in my scene. And my shadows and my darker areas, like underneath here, are lit appropriately. This also gives me an opportunity to talk about something that happens with the inspector or the editor. You see this, every once in a while you'll encounter this. This has been in Unity for like 4 years now. It's a really simple fix. All you have to do is just double click on anything in the hierarchy, and that fixes it. I don't know why it happens, but that's how you fix it. And so there we go. So now our lighting is better, it's smoother, and that's going to give us a nice consistent sort of canvas. Now, it may not look super dramatic, and you might want some depth and some shadow, and we're going to get to that. What we've done here, what I've done here, is I've set up a nice uniform sort of color palette to my scene that later, when I start adding post-processing, these cinematic effects, I'm going to have a nice, again, canvas to really enhance and improve and add some drama to the color and everything like that. So this just gets me to a nice even level, and then I'm going to improve from there.
Okay, great. So now we have taken a look at how we are going to light our scene. Very sadly, we've learned that some of Mike's amazing jokes have been cut. This is why you have to pay the big bucks to go to the actual training day in Austin. You can hear all of the real jokes live from the source. And I've got the wrong steps up. That's the steps that you want to see. So in cycle 3, we're improving light and reflections. We're dragging in the desert skybox. We're changing the environment lighting to color, setting the ambient color to a lighter color. We have an example hex that Mike used. We're going to select the directional light in the hierarchy, rotate it to a value of your choosing, and set its color a little darker, and then drag in the environment reflections prefab into the hierarchy. We've got lots of people in the chat chatting away, mostly about Mike's jokes. We have Mustafa Osman is asking, how does he move so smoothly with the camera? Mike's sort of preferred method of moving around the scene is to hold down right click and then use the WASD keys, which allow you to fly around the scene, which is pretty cool. I like to use that too. It's very useful. And so let's take a look. I'm only here for the jokes. I'm only here for the jokes too, BitBiteman, so we may be in the wrong place. Nice. Some folks saying the reflection probes make a lot more sense. Talking about how the track colliders were modeled, and Mike Cook from Cybernetic Walrus, the developers of Antigraviator, the game we're working with tonight, working with assets from tonight, says that they were probably modeled in Max. So you can model your collision meshes out of primitives in Unity if you like, or of course you can bring them in and use a mesh collider from another digital content creation package. One question, is it possible to see this live after it's over? Yes, this live recording, along with all my mistakes, will be recorded and available, but we'll also be publishing the clean edited videos as well, so you can skip all my silly talking if you want to. All right, let's take a look. Okay, yeah, we are sporting our own streaming platform now. This is Unity Connect. The stream is hosted via YouTube. And then we're doing the chat through Unity Connect, which is pretty cool. Connect is becoming a much bigger part of our world lately. We're hosting all of our live streams through it now. We're running contests like the Neon Challenge and the Machine Learning Challenge that we just had through it. And if you're not familiar with Unity Connect, I strongly encourage you to check it out. So let us speed ahead. We're going to go into cycle 4 now, building the vehicle. And we've got cycle 4 is broken up into 3 segments. We have cycle 4, building the vehicle, and then we have a section on the concepts of how the vehicle moves, and then we're going to look briefly at the scripts which we're using to move the vehicle as well. So I give you cycle 4, building the vehicle.
So at this point, we've got a scene, we've got some lights, we've got a little bit of reflection, stuff's looking pretty good. And so now what we're going to do is we're going to start working on the vehicle, the ship, which the ship is really the first sort of complex thing we're going to come across, and it's really the most complex object in the whole scene, or the whole game. So we're going to break it into a couple different parts and look at it a few different ways. So I have my scene here. And what I want to do is I'm going to find this sort of piece of ground here, this flat piece of ground. If you're having a hard time finding it, just follow the track. It will eventually lead you there. And this is where our car is going to start. Now, I would make a point to say that you want to point your car this way, but I don't think I should have to, because if you try to point it that way, you're going to have a bad time. And so you definitely want to face it down the track here. And now I'm going to go to my prefabs folder, and I have this ship prefab. And instead of dragging it into my hierarchy like I've been doing with all these other ones, I can sort of just position it where I want. And what's neat is if I drag it into my scene, it's going to track to the ground. It's going to track to the surface of whatever I'm dragging it onto. So I'm just going to drag it down here, somewhere kind of right by that shadow there, and just let go. And then here it is. And so now I want to talk a little bit about what is in this prefab. Why is it a prefab? So First off, we have the ship itself. There's nothing really special about it. It's just this empty game object. And then nested underneath the ship are 2 other game objects. So the first is the ship body, which has the ship body, ship plating, the transmission, and the wings. These are all just mesh renderers. There's no functionality on them. There's nothing special. All I really did when building this is I went into my models folder, I dragged in the ship body and dragged on the wings and dragged on the transmission and dragged on the plating. And instead of having to do that over and over for all of these and get all the placement completely correct, I just turned that into a prefab there. So there's your body, the plating, the transmission underneath, and the wings. Now besides that, there's also this sensor. And this sensor sits, ooh, way too fast, right at the very tip of the vehicle here. And all it is it is a capsule collider, right? So it is a physical capsule collider that is tagged as a trigger, meaning it's not actually gonna hit stuff, it's just gonna send up events when it runs into something. We're not gonna use this for quite a long time, but this is gonna become important when we finally make this game raceable, because that's how we're gonna know when we went through the finish line. When that capsule collider, that sensor, passes through the finish line, we're gonna say, oh, they completed a lap, or they completed another lap, right? And so this isn't super useful right now, but it's just here, and we'll, again, make use of it later. And so that is this whole ship prefab. And if I look too, the gracious folks at Cybernetic Walrus made us a nice Unity-themed skin. And so I've got this ship. Right now, I've dragged it in. It's lined up with my track well enough, but it's not facing my track. So I am going to click my rotate tool up at the top, or hotkey E, either way. And I'm just going to come down here to the little gizmo, and green is really hard to see on this vehicle, but trust me, I assure you it's there. There's a little green ring here, and I'm just gonna drag it, just sort of aim it towards my track. So maybe if I zoom out, it's easier to see. There it is. So I'm just dragging it, and that's just gonna rotate my vehicle. I just wanna face it down my track just like that. Cool. And now I need to add some stuff to my ship that's going to make it behave like what I want it to behave like, right? And so we're gonna add some scripts, and we're gonna talk about the physical concepts and all that in the next step here, but right now I'm gonna lay the groundwork for this whole thing. So first off, this is a physical entity. Unlike everything else we've added, which has just been like rocks and static stuff that doesn't move, stuff that just sits there, right? This is the first thing that's dynamic. It's an entity, it's a physical thing. It needs to push, it needs to pull, it needs to hover and accelerate and crash and do all the things that we need our vehicle to do. And so I need to flag it as such. I need to tell Unity this is a physically important object. And I'm gonna do that by adding something called a rigid body, all right, which is a physics term. And so with my ship selected, I'm gonna click Add Component, and then I'm gonna go to Physics. Now you'll notice there's Physics and Physics 2D. Physics 2D is our box 2D implementation for 2D games. That's not what we want here today. We're gonna go to the regular Physics, which is NVIDIA's PhysX library. And I'm gonna click Physics, and then I'm gonna select Rigid Body. Now I could just leave this go. As a matter of fact, if I were to just say hit play right now, the car would immediately disappear. And if I said, car, where are you? It's actually down here. There it goes, right? Because we said, hey, this is a physical entity, but we didn't really add any qualifiers to that. It has no boundaries, it has no physicality, it's not gonna land on the ground, it's gonna fall right through it, and we need to set some stuff up. So it's not so much that it's a physical entity, but there's some other important factors. So we're basically gonna treat this, since this is a sci-fi racing style game, we're not really gonna adhere to traditional real car physics, really. So the mass of our ship isn't really going to be important. We're actually gonna ignore the mass for most of the stuff we're doing. And we're also gonna ignore drag. We're gonna handle drag our own way. But angular drag is important, so I'm gonna set my angular drag to 3. And the reason I wanna do that is as I rudder, as I yaw my ship, move on the y-axis, as I collide with walls, I don't wanna like start spinning, right? So I want angular drag to stop my angular movement. So I'm just gonna set that to 3. I also am not going to use Unity's built-in gravity. We're gonna do our own thing for gravity, because gravity is gonna mean something a little bit different to us, right? We don't wanna always have a gravity of straight down. We're gonna have variable gravity, and we're gonna talk about that. Now, I wanna come down to collision detection, and I'm gonna click this little drop down, and I'm gonna select continuous dynamic. So discrete is nice for slow-moving objects or collision with large obstacles and things like that, but our ship is going to be going very fast. And not only is it going to be going very fast, but a lot of the colliders in the game are relatively small. And so if we're going really fast and the colliders are relatively small, there's a likelihood that we'll just pass right through it. And the game won't register that we completed a lap, or we'll fall right through the ground, or we might just phase right through another player, or anything like that. With continuous dynamic, it's basically going to do a more accurate check, which is going to prevent us from going through accidentally these colliders, and instead it's going to register them correctly. Now I am going to expand the constraints drop down here, and I'm going to constrain my vehicle as far as physics goes a little bit. So what I want to do is I want to prevent rotation on the x-axis. That would cause my ship to pitch up and down. And the reason I want to do that is if I hit a wall, I don't want to pitch up and over the wall. Or if I hit a racer, I don't want to pitch up the front of my vehicle and then drive and sit on top of their car and then hop over the wall and then be off into the distance, right? So by preventing physics from pitching my vehicle up and down, I can't pop up and go over something, right? We're going to control the pitching of the vehicle ourselves, right? So it adheres to the track. But we don't want physics to just do that as a result of collisions and stuff like that. I also don't want physics to be able to rotate my ship on the z-axis. I don't want it to be able to roll my ship. I don't want to be in a really strong curve, like taking a really hairpin curve, have some other vehicle bump me and just have me flip over, right? That would be bad, all right? And so physics is not going to be able to roll my vehicle or pitch my vehicle. However, I do want physics to be able to yaw my vehicle, movement on the y-axis. If you're ever in doubt of trying to figure this one out, yaw, y-axis rotation, yaw, right? So there you go. That way, if we're hitting a curve and we're hitting a wall, it'll rotate our car and as we're going around a curve instead of looking all weird with our car staying straight forward, right? And so these are the constraints we want here. So at this point, my rigid body is set up, all right? So again, I just know our angular drag of 3, no gravity with some continuous dynamic and some constraints. So that's well and good, but I still haven't defined any physicality to my vehicle. When it collides with something, what are its boundaries, what are its borders? And so I'm gonna do that now. I'm gonna click Add Component, Physics, and I'm gonna add something called a Mesh Collider. All right, so a mesh collider is a way that I can have a collider that's going to map pretty closely to a mesh that I have in my game. And so I'm gonna go ahead to where it says mesh. What mesh do I have? I'm gonna click this little circle selector. Anywhere you see that little circle, that's a circle selector. And that's gonna make a menu pop up here. And it's gonna say, okay, well, what mesh are we using? And I'll just type in ship, and that's the ship mesh. Now, I don't see anything right yet because this mesh is actually not meant to be a collider. It's too complex to actually be used as a collider, so it's not appearing. What I'm going to do is I'm going to say, you know what, simplify this collider by making it convex. When I click convex, you'll see that it now appears. There it is, all right, this green boundary around my car. It simplified the collider and made it work. All right, so we can see that there. So we're going to get pretty accurate collision. This is actually going to work better than if we had a true mesh, because if we had a true mesh, you would get hung up on this like hook here. And so now, since it smooths that out, you'll smoothly bounce off of objects and stuff like that, which is what we want. Speaking of that, all right, right now, by default, Unity colliders apply a friction of about 40% whenever something collides, right? And that's a bit extreme for our game. If we're racing and we tap a wall or hit some obstacle, we don't want to immediately have so much friction that it just destroys our speed and makes it impossible to recover and win or anything like that. So we're going to actually define a different physics material. All right, we're going to add a physics material that's going to remove all friction. And so what I'm going to do is I'm going to go to where it says material, and I'm going to click the circle selector. I only have one material defined. I called it Teflon. All right, so I'm just going to double click that to apply it. And if I want to look at Teflon here, I can just look down here in my project view. By the way, if you ever want to find some asset, all I have to do is just click on Teflon and it highlights it in my project view there. And all this is a physics material with no friction, no bounciness. So you're just going to glide off of surfaces. So collisions with walls are going to be handled, just by nature of how we're handling the propulsion of our vehicle. Unity is not going to slow it down by 40% every time it hits or anything, which would make the game much, much more difficult. And so at this point, I've got this ship, which has its rigid body on it, and it has this mesh collider. It's all set up, all good to go. If I were to hit play right now, nothing would happen yet. I don't have any of the behavioral stuff that makes it drive. It's just going to sit here. And in the next step, we'll add all the goodies that makes it actually a race car as opposed to just some mesh with a collider. All right, so it is your turn. What you're going to do for this step is you are going to, first off, navigate around in your scene until you're in this open area here. So you can place this pretty much anywhere in here that you want. You're going to go to the prefabs folder, and you're going to click on the ship, and you're just going to drag it into your scene. And then you can use the hotkey E, the rotate tool, to rotate it to face the track. Then what you're going to do is with the ship in your scene, you're going to click on it. So you're clicked on ship. And you're going to add a rigid body and a mesh collider. You'll do that by clicking Add Component, Physics. You'll add a rigid body, and you're going to add a mesh collider. On the rigid body, you're going to set your angular drag to 3. You're not going to use gravity. Your collision detection is going to be continuous dynamic. And your constraints are going to be X and Z. On your mesh collider, you're going to check Convex. You're going to make the material Teflon, your physics material Teflon. And the mesh is going to be ship_01. At that point, save your scene, and you will be good to go.
Okay, so that is the end of cycle 4A. We're setting up the ship prefab. We're adding a rigid body to have it interact with the 3D physics system. We're setting the angular drag on the rigid body to 3, unchecking use gravity so it won't fall towards the ground. Setting the collision detection to continuous dynamic. Under constraints, we're freezing the rotation for the X and Z axes, adding a mesh collider to the ship so that we can register collisions, making it convex, and setting the material to Teflon so that it doesn't incur friction when interacting, when we have collisions with the walls. And then we're setting the mesh for the mesh collider to ship_01. Now, we had a question in the chat from Maxi saying he had an issue with the child object, or with the collider coming in rotated. Turned out he had the ship body children child objects rotated, so keep an eye out for that if that happens for you. And generally speaking, if you have weird rotation problems that you need to solve, that's always my fix, is you could just add another child object, right, and rotate it where you need. Sometimes rotation is a tricky problem to solve, right? So just making a separate object and then just rotating it is always a good and easy fix. Yes, there was a question for Mike Cook about what was used to make the textures. I'm curious to hear the answer to that as well, because they look great. And let's see what else folks are asking. Some folks asking about the archive. Both this live version with the Q&A will be available, and then we will also have the edited versions on YouTube. So the answer is Substance Painter for the textures. Substance Painter is a super popular package. I actually have not tried it myself because I've never done really any texture authoring, but it seems to be really widely adopted lately, and people seem to really enjoy using it. So +1 for Substance Painter from the Antigraviator team at Cybernetic Walrus. Somebody asking to see the full cycle list. Yeah, we can. It's here. It's right there. So we are going to go through building the vehicle here, which is going to include what you just saw, and then also the concepts for the movement and the scripts. Tomorrow, we're going to do the camera rig, VFX particles, post-processing. I'll talk about what we're going to do tomorrow in a minute. 1, 2, 3, 4. Whoop, that's the next one. This is the one that we're on. Okay. Cool. So, good. Sounds like folks are on track. And yes, if you want, of course, you can rewind on YouTube. That's something that some folks have pointed out. There was a little issue with stream buffering. Hopefully that's solved now. But if you want to, you can use You can use YouTube's, another thing with a U. You can use YouTube's DVR functionality to scrub around in the stream. So you can actually go back in time, which is kind of a cool thing that you can't do on Twitch, which is the other streaming platform we were using. Okay, that being said, let me jump forward, and we are going to continue first looking at the concepts which we are going to use to move our ship.
So where we left off, we finished the last step here with the foundations of our ship in our 3D level with some setup reflections and lighting and whatnot. And we add the rigid body and the collider and all that, but the ship just sort of still sat there. So what we're going to do now is we are going to talk about how we're going to make this actually a vehicle, a racing game, right? How we're going to make this work. So we're going to start off by covering some concepts here, all right? So before we get into talking about code, before we get into actually applying stuff to our vehicle and turning it into this racing game, it's really important to understand what we're trying to achieve, what the physics is actually going to be doing. We actually are not going to be doing live coding today because it's not that important. I always hold the belief that if you're a programmer, then you kind of already know a lot of this stuff and you don't care. And if you're not a programmer, then you don't know any of this stuff and you don't care. All right? And so no one really benefits from live coding. Okay? So instead what's going to happen is we're going to explain the concepts of what the code's doing. We're going to look at it, and it's all commented and everything, and then we're going to use it. And if you have any code questions, we're going to have plenty of time for Q&A. You can ask me. We can walk through specific bits or whatever. But for the most part, the actual code is less important than what we're trying to do with it. And I feel that's what we really want to focus on. First off, there are some controls we're interested in. All right, these are the things that we are looking at from the player. We are interested in the vertical input axis, which we are going to map to this concept of thrust, or the thrusters of the ship, what's going to propel it forward and backwards. We are interested in the horizontal axis, which is going to be our rudder. And our rudder is going to be used to yaw the ship. Remember, yaw, rotate on the y-axis, yaw the ship. And then finally, we're going to have a brake button, not an axis, to say, are we applying the brake? All right, and we're going to have a couple different types of braking and things like that. So those are really the inputs that we care about for this project, just these three. All right, and I had mentioned before, we're not using Unity's built-in gravity. We're actually using some custom gravity. We're going to handle gravity ourselves because the way we apply gravity is going to be different depending on what scenario we're in. So really, the way the vertical physics of this game works is our vehicle is applying some hover force. It's lifting itself up, right? It's a hover vehicle. And we are going to have some gravity pushing it down. All right. Now, when the ship is over the ground, when the ship is just basically hovering over the track, we're going to have a normal amount of gravity. I say normal, it's actually fairly extreme. So Earth's gravity is 9.81 meters per second squared towards the center of the Earth. That's what's pulling us all down if we're at sea level. But we are applying around 20 meters per second squared gravity down. So a little over double Earth's gravity. And this is important because our ship is going really, really fast. And when we played around with this, and when we looked at the original version of the game, regular gravity was too slow. It felt like we were just floating. And we really wanted it to pull us to the track. And so we are going to apply a greater amount of gravity. Also, when we leave the track, so if we were to make a jump or, just any time we're above the track, so far above the track, we're going to apply a significantly larger amount of gravity to quickly pull us down to the track, which is going to make jumps feel very fun. All right, so when we go over it, it's going to pull us down to the track, right? It's going to feel pretty cool. All right, we're going to talk a little bit about how we calculate that hover force in a moment here, but it's also important to know that this gravity that we're applying, which we could just modify Unity's physics to change the gravity through the physics settings, but we're not. We're applying it ourselves because gravity isn't always going to pull us straight down. All right, as a matter of fact, gravity is always going to pull us towards the track. And what this is going to do is this is going to allow us to simulate centrifugal force. All right, so if you're ever doing a loop-de-loo, right, or the car goes up and over, right, why when it gets to the top doesn't it fall down, right? It's because of the concept of centrifugal force, which is an imaginary force, but at any rate, it's what makes the ship stick to the track. So instead of gravity pulling us down, gravity is going to pull us to the track. Right, so that we can make these banks and go upside down and all this other stuff. And we can see that here in this image, right? The track is represented by this cube, and the ship is tracking to the track, right? It's seeing what's called the normal of the ground, so the arrow pointing directly away from the ground, and it's aligning itself to that. So it wants to adhere to that while it's hovering. When the ground disappears, if there is no ground, either you've made a jump or you've flipped over or whatever, the ship is going to automatically use just world up. The upward and the y-axis is the new ground, which means it's going to self-right itself. It's going to flip back over, all right, in case it were to roll for any reason. It's going to self-right, and then it's going to apply this greater gravity to get us back to the ground quickly, as we can see in this image here. So that's effectively what's happening. So we're applying two types of gravity, depending on whether we are on the ground or not, and our gravity is always pulling us towards the track. All right, which is going to make it feel much more cool. You're going to really feel the velocity as it's pushing you into the track, as opposed to just pulling you towards down, which may not make any sense depending on where you're at in the course.
It's probably important to point out that the track isn't entirely flat the whole way around.
Right, exactly.
So rather than the ship kind of remaining relatively upright on the side, it actually banks with it. And you'll notice this a lot more when we
Exactly.
go into play mode.
Exactly. If you were in a hairpin turn and you had your ship and gravity was pulling it down, you would just start falling off the track, which is not what we want. We want to be pushed into the track, and it's going to adhere to the track. It's going to feel much better. So I talked about this hovering. We have this hovering concept, and we could just apply some force to the vehicle to lift it. However, we're going to find that that never really gives us good results. All right. If anyone's ever tried to make a hover game or seen any of the articles or anything you'll see everywhere on the internet about making hovering games, what always ends up happening is your vehicle is pushed up by a hovering force, it gets to its maximum height, and then gravity pushes it down, and it gets caught, and it's pushed back up, and it just does this over and over and over again. And it never actually sits where we want it to sit as far as hovering goes. So we're actually going to control this using a concept called a PID controller. Now, this is not unique to Unity. This is not unique to this game. This is a concept that you can find in microcontrollers and robotics, in electronics, in self-driving cars and drones and everywhere. The concept is just PID controller, which stands for proportional integral derivative. Now, the nice thing is it's not super important for you to understand how this works. It's not, like I said, it's not a Unity-specific thing or whatever, right? Instead, we just know that we're going to be able to pass a value into it, and it's going to give us a value back. And that value is going to get us to where we want to be. But to further explain the concept of what a PID controller does, we're going to look at a couple scenarios. So what we're used to doing is something that you would just maybe consider a proportional control or a P controller. And what that is if you're using, say, like lerp or just applying some force, or if you're saying, I want to go there and I just continually push myself towards a spot or whatever. And what ends up happening is you overshoot. Right? If I'm saying, keep pushing myself in that direction, and then I get to the spot and go, no, wait, I passed it, turn around, and then I pass it the other way, no, wait, turn around. That's effectively what we have when we're just applying a force. The ship goes up, passes the line, comes down, passes the line, and it never reaches the line because it just bounces, right? And so that is what happens when we just apply a proportional amount to this equation. When you have a PI, proportional integral controller, right, it gets a lot better. The integral component counterbalances the proportional one, and you get really close to where you want to be, but there's always still a little bit of oscillation, a little bit of error in there, and it's never quite exact. And then you add a PID controller, and you get exactly what we want. A car that will lift up to the right height and stop, which is exactly what we want. And again, I can't emphasize this enough. It may seem confusing or the code may not make sense, but that's fine. It's kind of a black box thing. This is a common just controller type in all sorts of different industries. We are just applying it here to get our vehicle to behave the way we want it to, as we would want it in a real life hover car, right? That would get it to the right height and then hold it there, which is exactly what we're going to do. Now, as we're driving, we need to figure out how we're going to do yaw and then banking. And so again, yaw is that y-axis rotation, right, to make our vehicle turn. Now we're also going to add banking, and banking is a purely cosmetic portion of the game. Yaw is enough to get our vehicle to turn, but the bank makes us as players say like, yeah, I'm going really fast, I'm banking into this turn, and it feels really cool. And so we can see here the difference between the two. We have one ship on the right that is simply yawing, right, just with the rudder. All it's doing is turning. And it's effective, but it's kind of boring. And then the ship on the left is actually banking 30 degrees into a turn, which feels much more cool. All right, and so again, that's what we're doing. It's a cosmetic addition, but it makes it feel more real as a player. You have this banking and you have this yawing concept, all right, and that it's going to be applied to the ship's body. Finally, we want to talk about the counter forces that are being applied to our vehicle. So we're propelling forward, that's easy enough, and we are lifting up, which is a little bit more complex, the hovering with the PID controller and stuff like that. But really, the racing game is also very much about the counter forces. What is preventing us from going in infinite speed? What is preventing us from flying off the track? What is preventing a lot of this stuff from happening? And so we have three distinct counter forces: brake, drag, and friction. All right, so first and foremost, our vehicle is going to have some velocity. It's going to be traveling in some direction with some magnitude. It's going to be moving, right? And when we apply a brake, our brake is not, in this instance, going to be a counter force pushing in the opposite direction. Our brake is just going to be a subtractive force from our velocity. It's just going to reduce our velocity exactly. We do this so that if we counter brake, we push against our vehicle, we reach zero velocity, the brake would then make us start going backwards, but that's not what a brake does. So instead, a brake wants to reduce your velocity to zero. That's what our brake is going to do. So brake is going to directly counter our ship's velocity. Now, we're going to break our velocity into two parts: the forward speed and the sideways speed. All right, the forward speed is how much of our velocity is going forward down the track, and the sideways speed is how much of our velocity is us bouncing off of a wall or trying to skid around a corner or losing the grip on the road or whatever. Now, the forward speed is directly countered by drag. Air resistance is just the drag that's being applied. That's what's going to prevent us from reaching our terminal velocity, or if we're going above terminal velocity. As we go faster, drag gets bigger and bigger and bigger until eventually our drag is so great that we cannot possibly go any faster. That is what terminal velocity is, and that's how we're applying it. So drag is always reducing our propulsion until eventually we just can't go faster. Now, our sideways speed is being countered by friction. That's what keeps us on the road. If we had zero side friction, when we tried to turn, our car would turn sideways, but keep going the same direction and slam into the wall, right? Like all the 8th graders at a roller skating rink, right? No turning whatsoever. If we have perfect friction, which this game does, we never slide. We can't drift. Anywhere in between gives us a variable control to if we want to have drifting in our game. Now, this particular game is going to have perfect side friction. You'll never drift. You'll hug curves and all that stuff, right? You won't slip. But if you reduce the side friction at all, and I have in the code, I have a comment right here is where you would do it, you could add drifting if you wanted to, just by reducing that by some factor, right? And you can control how much you want to do that. But those are the counter forces there. The last little bit of force that we need to know about are our collision impulses. So when we collide with a wall, right, you have the concept of the equal and opposite reaction, right? We're going to slam into a wall and the wall is going to push back against us with some equal amount of force. However, there's always a little bit of that force that gets let off in an upwards impulse. So we slam into a wall and our car kind of wants to pop up, right? Just a little bit. And it's enough that our car could pop up over the wall and escape the track by hitting a wall fast enough, pop up and get out. And we don't want that to happen. So whenever we collide with a wall, we are going to calculate how much of that impact is trying to make us go up, and we're going to push an equal amount of impact straight back down, right? So that's going to keep our vehicle on the track. So our vehicle can't go over the track because we're pushing it right back down. Right? Now, those are the important physical concepts that we're dealing with, right? So we've got our friction, our drag, we got, the braking, we've got hovering, we've got propulsion, we've got all these different concepts, and now these are just going to be applied through code. And again, I'm going to go through the code relatively easily. I don't want to go line by line. No one wants that, trust me. But all of the code is completely commented. All right, and so we are going to just see how we can make this stuff work, how we can turn these concepts into a reality. Switch to.
Okay, so as we've seen, right, so we've laid out the concepts. These are the basic steps. Whoop, not for that. These. Nope. These are the basic steps, and then now we're going to take a look at, so basically we're applying a script that's already been written, right, and setting a couple of steps. These are the steps we'll do after we explain the scripts. Do I have a card for this? No. Okay. And so what we're going to do is we are going to, let me just take a couple questions from the chat. We had a couple interesting questions about the AI. We're not covering AI in this lesson, right? We're full worth being clear about that. But in Antigraviator, the full game, which you can check out on Steam and at antigraviator.com, the AI is used, the waypoints are used as a basis, but then there's more complex AI for overtaking opponents, right, going around other cars, and also using some rubber banding. Rubber banding is an interesting concept that you get in video game racing games, where basically you never want to have any one opponent just completely dominate, go way out in front, and lap everybody else, right? What you want to do is you want to try to always keep people within range of each other so that somebody might win, right? Mario Kart is probably one of the most famous examples of this, where they have all the different shells, which allows somebody who's way back in the back of the pack to catch up to the leader. And they also do some stuff with actually controlling the speed of the cars so that to keep people close together and to keep the race exciting, right? So totally not fair, not competitive, but actually makes games like that more fun. And so interesting to hear that there's a little bit of rubber banding involved in the AI of Antigraviator as well, which makes sense in a single player game, right? If you're in a single player situation, you probably want the AI to be kind of playing around the player, whereas if you're playing two-player or multiplayer, you're probably, you may want to take a different approach. So interesting points there. Okay, let's take a look. Yes, somebody compares it to the director, the AI director in Left 4 Dead. It's exactly, right? It's a kind of a hidden system which is designed to make the game more fun by kind of manipulating the outcome. It's an interesting one. Okay, so what I'm going to do, let's just keep going because we're getting to time. So we're going to now walk through the scripts. This will be our last module, our last cycle, and then we'll take a little time for Q&A at the end, and we'll wrap it up, and we will be back tomorrow. So we're continuing our session tomorrow with more hover racer training using assets from Antigraviator, the game. Let's check out what I'm calling Cycle 4.2 or Cycle 4B, which is walking through the scripts.
So I'm back in my project here, and I'm going to go to my scripts folder and right down here. And I've got two scripts that I'm interested in, but I'm going to open up first off the player input script. Let that open there. Give this a second. I forgot to have Visual Studio already open. All right. Does that look readable? That looks readable. There we go. So the player input script, like I said, it's all commented, right? So you can see what the script does. You can see what every single line of this code does. So you never have to worry about what is something doing. So basically, we are going to define the names of our input axes, so vertical, horizontal, and brake, right? That's what we're just checking our inputs for from the player. All right, and then we are going to have some public variables called thruster, rudder, and is braking. All the other classes are going to say, hey, player input, are you applying a thruster? Are you applying a rudder? Are you trying to brake? We don't want these to be directly editable through the inspector of Unity, so I just have a little tag here, hide in inspector. So even though it is public, you won't see it in the inspector in Unity, which is cool because I don't want people messing around with those. The code is going to handle those. They need to be public, but we don't want to be able to see it. Inside our update, first and foremost, it's good to have a way to leave the game. A lot of times people will make a build of this, they'll run it full screen, and then they say, well, how do I exit? Oh no, now I've got to force quit the game or whatever, and they have no way to get out. So the first thing we're going to do is we're going to say, hey, if ever you press the cancel button, which is the escape key by default, and you're not in the editor, means this is an actual build, then let's quit the game, which is important, so you can actually leave. Here we have some code that's asking about a game manager. Now we don't have a game manager yet, so this code isn't going to do anything. But eventually it's going to say, if we have a game manager and the game has not started, then we have no inputs. That way the player can't drive while the game manager is initializing or the cutscene is going or anything like that. All right. Finally, all we're doing is we're just getting the thruster, rudder, and braking from our input system by saying, hey, input, give me the values of these axes and buttons. All right. The other script I'm interested in is the vehicle movement script. This is the most complex script by a lot in this entire project. All right, this is where all of that physics stuff we just talked about is contained. Okay, so you may have some questions about it, but again, it is all commented. There's going to be nothing secret in here about what I'm doing or what's happening. This is all based off the real code from the actual game. It's simplified quite a bit, but it's all how this game is actually run and how these ships move. And the team has done, the Cybernetic Walrus team has done a fantastic job building a game that's compelling to play, and then we just spent time just kind of simplifying it and making it a little bit more human readable for these training day. So fantastic stuff. So the ship will always have a reference to its speed. That's just how fast it's going in the forward direction. The speed is how fast forward it's going, ignoring any velocity from hovering or sideways or collisions or whatever. We have some drive settings, which is just how much force does our engine apply. And we have our braking factors. So we'll see here like slowing velocity factor, braking velocity factor. What this says is if we don't press the thruster, if we just let go of all controls, we are going to maintain 99% of our velocity every frame. Every frame we're going to lose 1% of our velocity. We're just going to start slowing down. All right? If we apply our brake, we're going to lose 5% of our velocity. Straight off our velocity, just 5% reduction. Right? So our brake is going to stop us much faster than if we just let go of the controls. Angle of roll is just how that ship is going to bank. The hover height is how high we want to be. Max ground distance is how far we're going to look for the ground. And then we've got our hover force. And we're going to use something called a layer mask to define what is the ground. How do we know if the thing underneath our ship is the ground, is the wall, is another player? We don't want to be able to hover off the top of another player and fly over a wall, right? We're only looking for what we consider to be the ground. And so we've defined a layer mask that's going to say this is the ground. Anything on this layer is the ground. And then here's that PID controller I talked about. Again, it's not super important to know how it works. It's kind of black box. It's just a concept. We're going to say hover PID. This is where I am. This is where I want to be. How much force should I apply? And it's going to give us a number. Right? It's kind of a magic 8-ball sort of thing. Set our physics settings. We're just going to define a terminal velocity of 100 meters per second. And then what's our hover gravity versus our falling gravity. All right, so then basically the meat of this script is that inside fixed update being like regular update, except this is where we apply our physics. All physics calculations should be done inside fixed update. We're going to calculate our speed, and it's not super important for you to understand dot products and stuff like that for vectors, but suffice to say, we just want to say, hey, velocity, how much of you is forward? And it's going to give us a number. Cool. It's basically just figuring out some percentage amount for us. How much of our velocity is in the forward direction, and that's our speed. We're going to calculate our hover and our propulsion, which is going to be simply in hover. We're going to say, all right, let's generate a ray, an imaginary line straight down. And we're going to say, hey, physics, shoot out that ray for me and tell me, did I hit anything on the ground layer that's within my max distance? If it says yeah, then I'm on the ground. If I'm on the ground, I'm going to say, okay, well, tell me the angle of the ground, the normal of the ground. Tell me how much force I'm going to apply upward to hover based on how far away I am. All right, and then we're going to just calculate and add some hover force up and some gravity down. Right, that's the force up is going to push us away, the gravity down is going to push us back towards, and those two forces are constantly fighting each other. Hover wants to lift us away from the ground, gravity wants to bring us right back down, and that's what gives us our nice central amount there. If we're not on the ground, then ground is just pointing up, and we don't apply any hover force, we just apply strict gravity straight down. The code after that is just the code that aligns our ship to the ground and handles our banking cosmetic, which is based off of our rudder here. Again, I don't want to get into a lot of the math parts of this, it's all commented, but basically this is just what tracks us to the ground.
You don't want to explain quaternions?
I don't want to explain quaternions, and right now I don't particularly want to explain projecting on planes either. Suffice to say, we're going to say the ground points this way, I want to point this way, and that's what we do. And we make our ship do that. So yeah, and no one really wants to explain quaternions, I don't think. Okay, so the next thing we're going to do is we're going to calculate our propulsion. And to do that, first thing we're going to calculate, all right, how much rudder are we applying? So we'll calculate some torque, and we'll apply the torque, and that's just what turns our ship, yaws our ship. We're going to calculate our sideways speed, very much like we did the forward speed. Again, there's that dot product. We're going to say, hey, velocity, how much of you is in the right direction, directly to the right of our ship? That'll tell us how much is sideways. And we'll apply a perfect friction. So this is where I have this little note. If you want to add drifting to the game, All right, so here's our perfect friction, our side speed divided by time.fixed delta time. If you were to, say, further divide that by 4, then all of a sudden you would be sliding all over the place. I don't want to do that, but you could. Right there is where you can add some Tokyo drift if you really want it. So then basically we're going to slow down our vehicle if we're not applying thruster. If we are on the ground, we're going to apply some brake if we hit the brake key. You can't brake in midair. You can only brake when you're on the ground. I don't know why, but it's just how it is, so whatever. So we brake while we're on the ground. And then for propulsion, also only applied when we're on the ground. We're just basically going to say our drive force times our thruster, minus, and here's that drag. This is the drag that continues to get bigger and bigger and bigger. And so as we get faster and faster until eventually it caps out at our terminal velocity. When we collide with something, we're going to say, hey, did we collide with a wall? If we collided with a wall, we're going to say, oh, here's that dot product again. This one becomes important. Hey, collision impulse, how much, collision force, how much of you is up? All right, and then we're just going to say, okay, we'll take that and we'll apply the negative version of upward force from collision. So upward force from collision says we're going up. We're saying, nope, we're coming down with the exact equal amount. We're not pushing into the ground. We're just adding enough to completely neutralize the collision and keep us on the track. And then we have some other get speed percentage, which we'll use later. Okay, so that's all this code. Again, all fully commented. If you really want to dig into it, feel free, be my guest, all that stuff. If you have questions, definitely ask them. But actually applying these to the ship is relatively simple. So I've got my ship, and I'm going to come down here to where it says player input script. By the way, it can be difficult to read the names of these scripts if they tend to be longer. So you could come down to the bottom of the project view and just drag this slider here, which just makes the icons smaller or turns them into a list, or makes them bigger or whatever, or a flowchart code there. I'll just make them bigger. That works for me. And I'm going to locate the player input script. I'm just going to drag it right onto my ship. And note that I don't need to make any changes. I've just defaulted it to the input axes we have. If for any reason you were to define different input axes or want to change the names, you would just change them here. And you might be wondering, well, where are these input axes? Like, we might be familiar with vertical and horizontal, but is anyone familiar with a built-in input axis named brake? Probably not. And so those are already set up here. If I go to Edit, and then Project Settings, I shouldn't have zoomed in when doing this, and then Input, you'll see over here in the Input Manager, under Axes, I've set up some axes. Begin game controls, end game controls, so you can see exactly where all of our game-specific stuff is located. So if you weren't able to find it, there it is. We have our normal horizontal input axis, but I also supplied a second one that makes this work with joysticks. So if you have a controller you want to play this game, it will work right out of the box. All right, again, that's our horizontal, vertical, I have both the keyboard and the joystick. And for brake, I have both the keyboard and the joystick. So we can play with either keyboard controls or with a game controller if we have one, right? And all that was is just me just typing in the values there ahead of time. So that's our input. So now I want to handle the movement. So again, I'm just going to grab my vehicle movement script, just drag it into the inspector of my ship. And it's going to have all these default values I set up. The ones I need to set up here is, first off, what is ground? Well, what does that mean? So if I look at my track, if I look at the road collider, I will see that the road collider is on a layer called ground. There's actually quite a few of these layers. All right, I could put it on post-processing or wall or UI or water or whatever, but it's on ground. So if I click on this ship and the ship says, okay, well, what is ground? The layer mask lets me click and say, oh, I can select anything I want to be ground. Well, I want the ground to be ground. Yeah, sure. Maybe I wanted water to be ground. I don't have any water, but I could. I want everything to be ground. Would be a terrible idea because then you would just drive right over walls. So don't do that. But I'm going to say ground is ground. And then it's going to say, okay, where's my ship body? So the ship body is not the ship itself, but again, the ship body, because it wants to turn the body even more to make for that banking action. Right? The ship itself is just turning. The body of it, the graphical parts are going to be banking, right? Rotating even more. And so I could click and drag that over onto that property, or much easier is just, I'm going to click this little circle selector here. It's going to pop up with every game object that's in my scene, and I'm just going to type ship, and then ship body right there. All right. And so now I'll save my scene. I'm going to hit play. And granted, the camera's not set up yet, but a ship is there. It's floating, see? And if I go to my game, right, again, it's kind of hard to see. Maybe zoom in a little bit. There it is. And I'll just, whee. Don't worry, we'll get the camera set up here shortly.
This is the difficult mode. You have to race the whole track.
Nightmare mode, yes.
Although, how many times have you played it? You could probably do it by memory.
I highly doubt I could do this from memory. It's just like, bye guys, crash, crash, crash. I'm hitting every wall I can find. There you go. The next step, we'll talk about the cameras and we'll make all that a lot better. But at this point, I have a fully functioning, physically driven car with custom gravity and collision forces and braking and all this really cool stuff. All the really complex stuff that goes into the physics of a racing game. All right. So this was a lot of talking on my part, but it's a fairly easy step. What you're gonna do is with the ship selected, you're just gonna add these two scripts. So you can go to your scripts folder and drag them onto your ship, or another way you can do this, if you don't wanna drag from your project view onto the inspector, you could always click Add Component, go to Scripts, and that lists every script that's in your project, and then you could just add them through here. And so what you wanna do is you wanna add the player input script, which is gonna require no changes, and then you're also gonna add the vehicle movement script. Now the vehicle movement script, you'll want to change the what is ground to be the ground layer. And you'll also want to change the ship body. You'll just click the circle selector here and you can just type in the search bar ship and then select ship body. If you really want to play around with the PID tuning, you can certainly do that. But I warn you, if you mess around with this too much, the ship might start bouncing all over the place. Those PID things tend to just need a little bit of tuning. And so there you go. And then when you're done, you can hit save your scene and you can just come on up here to the top, hit play. And then while you're in play mode, WASD will just let you sort of fly around there. Shift is brake, and you can just drive around for now. So it came to my attention that some people don't have a ground layer, which may have just been something that happened importing with a different version or whatever. So I'm going to take a quick second here, and I'm just going to tell you how you can get that back. So what I'm going to do, and you guys can just follow along on this part if you don't have the ground layer. I'm going to go up here to the top of my inspector, or my editor where it says Layers, and I'm going to click the drop down here, and you're going to see that I have a couple layers that I will be using today. These are post-processing, ground, and wall, and you probably are missing those. So what you're going to do is you're going to go down to the bottom and just click Edit Layers. There you go. And I'm going to expand the Layers section, and you'll just want to type these in. Now the names aren't super important because we'll just be identifying these directly, but you're going to need these three layers: post-processing, ground, and wall. All right, so, and you can add the other ones as they become relevant later, but these are the ones we want. Right now, really ground and wall are the super important ones. But post-processing, ground, and wall. Now, once you add those, it just becomes a point of adding stuff to those layers. So I want to click on my ground here. So if I go to my environment, and I go to my sand floor, I want to make sure my sand floor is on the ground layer so my ship will hover and drive. Right? It'll detect that that is the ground. I want to do the same thing for the road. So if I expand my track and go to my road collider, that is also the ground. Finally, you'll want to click on the wall colliders and make sure those are just on the wall layer. So sorry that happened. It shouldn't have, but I guess just importing stuff, whatever, you lost the layers there. And so again, the sand floor, this piece of terrain here that is the floor, needs to be on the ground layer. The ground collider of the track, or road collider of the track, need to be on the ground layer. And then finally, the wall colliders need to be on the wall layer. Those are what you need for the physics to work correctly, so the ship knows what is a ground and what is a wall. All right, we have identified the problem with the layers and the inputs for those of you who have that. And this is my fault for not explaining how we're going to open this project. So if at the beginning of the day, you went to the files, and you went into, say, like the project, you went into assets, and you went into scenes, and you just opened up one of these scenes. What effectively happened is it created a project and loaded all these assets in for you, but it lost all of the project settings, right? The things that were part of this project. And that was my fault. I really should have done that step as well. So you're going to go to, let me just click that again. You're going to go to File and then Open Project, and then Open. And under the training day files, I believe you're just called Hover Racer, you're just going to click on the folder. Hover Racer, underneath you should see assets and project files and stuff like that. And you're just going to, again, just click on the Hover Racer folder and hit Select Folder. That opens the whole folder as a complete project with all of the settings and everything else. Then you'll have all your layers, you'll have all your inputs. I do apologize for not doing that step. So if you just started by opening the scene and everything up until now seemed like it was perfect, you were missing the layers, you were missing the other stuff, and that should get you squared away. If you lost work or you moved stuff into your own project or whatever, again, you can always go into the scenes folder, the completed folder, and just, if you open up the 04 building the vehicle and open the scene, you will be exactly where we are right now.
Okay, and that is our show for today. So we will be back tomorrow with more hover racery goodness. And I keep putting up that Global Game Jam title card for some dumb reason. It's labeled something similar to my monitor, which is UX fail on my part. And so we will be back at the same time tomorrow, 9 p.m. my time. That'll be 8 p.m. GMT. Plan for about an hour and a half or an hour and 15 minutes worth of content. What did we get to time-wise? Let me look at my laptop. We got to, 10:30. So this took us about 90 minutes to get through, including pauses for Q&A and stuff. So plan for something similar for tomorrow night if you would like to attend. The videos will be releasing on YouTube in exactly 1 minute. So you can grab those there. And then there will be a automatic archive of this with all of the chatting that will be available on YouTube as well. I'll probably make that unlisted, but I'll put a link in the chat here for those of you guys who want to watch it. Thanks so much for everybody who's giving us nice feedback about the chat. Look forward to seeing you all tomorrow, hopefully. It should be a lot of fun. We're going to continue. Let's see if I can bring up the... well, we're going to do that. We're going to bring up... we're going to look at the camera rig using Cinemachine, adding VFX and particles, applying post-processing. We're going to be looking at the post-processing stack V2, including post-processing volumes. And we're going to do mixing the audio. I think mixing the audio is the last one for tomorrow. And then on Thursday, we'll do the game manager, lap times, ship UI, countdown, and then the sequencing for the intro cutscene will be on Thursday. So please join us for that. I am going to open up the floor to a little bit of a chat with our audience here on Unity Connect, and we can answer any further questions that you have. So just go ahead and put those in the chat, and I will answer on the microphone. And Mike and Mike, Mike Geig from Unity Technologies, and Mike Cook from Cybernetic Walrus, developers of Antigraviator, which is the game that graciously loaned us some of their assets for use in this training day. I want to remind you to sign up for their newsletter at antigraviator.com and also to wishlist Antigraviator on Steam, because you can do that today. And we've got links in the central chat for you to do that with. So thanks so much to Mike Cook for attending, to Mike Geig for attending as well. My name is Matt Schell. I'm an online evangelist here at Unity Technologies, and I do these live streams every week on Wednesday nights. So come and see me again sometime. We've got a listing of all of the, let me link to that actually. We have a listing of all of the events coming up on our Unity Connect events page, and I'll put that on the chat. Upcoming events are here. And yeah, okay, so let me take a look at the chat and see if we have any questions that we need to, lots of questions, okay, or lots of comments anyway. Okay, cool, lots of nice positive feedback, always appreciate that very much. We're working hard to bring this stuff to you guys, so it's always nice to hear when you enjoy it. Thank you to everybody saying thank you for the stream. Nice to hear. We've got some people, Gareth Evans saying great stuff. My first visit back to Unity in a few years. Welcome back. Glad to hear it was useful. Unity has come a long way in a few years. So if you haven't used Unity in a long time, might be time for another look. We got the Snuggie idea from Paul Swanson. It's a winner. Thanks again to Mike Cook for joining. Super awesome. Biddy says, just a note to the Unity people, this tutorial was great. Hard to find any good tutorials. Well, all credit where it's due to Mike Geig and Andy Touch, who actually created the training for this training day. And a reminder, this is a recording of a live event that took place at Unite Austin last year in 2017. So if this is something that seems exciting to you, you can join us for one of our live events in the future. We will be running many Unite events around the world coming up, and some of them will feature training days from your friendly neighborhood evangelists. So watch this space and join us live sometime. They're great events. It's a whole day-long event. We're getting the kind of cut-down, condensed version here, but you know, joining for the live event, it's very interactive and awesome. All right, let's see what we got here. Whoop, my Connect notifications are popping up on the monitor. And let's see, okay. Cool, nice. Folks saying they're excited for part 2 and 3. Some folks talking about the spline solution used, which was DreamTech, I believe, Dream T-E-K, T-E-C-K. Folks talking about the physics. I haven't totally followed that conversation. Talking about canceling the impulse force, but not all of it. I haven't totally caught all of that. Luis is asking if it's better for protecting variables, the internal mode, or just hiding the public variables. The reason that we have public variables is because we want them to be accessible from other classes, from other scripts, but we don't want somebody working in the Unity editor to be dragging and dropping things into them or modifying the values without understanding exactly how they're going to work. So hiding them in the inspector just kind of says, hey, this is not something that a designer is going to need to edit. This is going to be controlled via a script, but then they're still obviously accessible to other classes in terms of their protection. Okay, cool. DreamTech is on the Asset Store. Yep, I encourage you to check out the Asset Store if you're not familiar. There's a lot of great stuff there. So please do check that out. DreamTech Spline is in the Asset Store. We'll quote that because that's worth mentioning. Okay, let's see. All right, I'm just going to read back a little bit, see what other questions we have. I see. The original question was why did they cancel the upward velocity by adding a negative force instead of just setting the y velocity to 0? Yeah, and as Mike says, you only want to cancel the impulse force, not all of it, right? So you don't actually probably want a velocity of 0 in this case. You just want to subtract any force that's moving in a direction that you don't want to move it in, right? So it really just kind of precisely nullifies that force. Okay. Good. Ackley is asking, why use the surface normal instead of interpolating between the vertex normal of the mesh for determining the orientation of the car? And Mike points out that the track can bend, and we want the normal of the part that we are over, which is also more accurate and simpler. Mike's doing a great job with the questions tonight. Man. Thanks, Mike. Thanks to both Mikes for joining. All right, how are we doing on time? What time is it? 10:38. Okay, so let's give it another 5 minutes. So if you guys have last questions, fire them into the chat, please, and we'll do our best to answer them. It's getting a little late over here in Germany. It's 10:40 in the evening, and I got to go relieve my babysitter, so I'm not going to stay for too much longer. But obviously, we can cut the stream and keep the discussion going in the chat as well. Abdullah asks if this game is suitable for mobile devices. My gut feeling is that no, this probably is not suitable for mobile devices. You could probably make a game like this that was a bit scaled back, but this game in its current state probably would only run on higher end devices or more powerful devices. Yeah. Yeah, as Mike puts out, the post effects would be expensive for the GPU of a phone, and the full game targets PC and console. So no, basically no. That being said, you could use many of the concepts shown here to build a new mobile game kind of in this direction, but certainly this game is not targeting mobile. Yeah, your phone will probably melt. Yeah, I mean, the modern phones are getting more and more powerful, and if you target, a narrow range of the newest phones, you can do a lot, but the challenge for most mobile developers is that they want to target the widest addressable market, right? Which means, supporting an iPhone 4S or whatever, and whatever Android devices, whatever 999 million different Android devices are out there with all their different specs. So that's where things get challenging on mobile. Getting something that runs nicely on an iPhone X is not the hard part. Yeah, as somebody's asking about, hey, is there another spline tool I could use? And Mike Cook points out you could just write your own spline tool. The one that they bought to save time, which I think is a very valid approach, right? Buying the things that you need. If you can find something that works and buy it on the asset store, that's almost going to be always cheaper in terms of man hours and effort. So definitely consider that. Cynail asks, if I made a game project on Unity on free services, will I be able to share it with the public and friends, or do I need to pay for this? Yes, you can share it with your friends, and you can even publish it and charge money for it. Our EULA specifies that once you make more than, I believe it's $100,000 a year, that you need to buy a pro license. Which we feel is a very generous model. But obviously, please read the EULA yourself, something that not everybody does, and would be a good idea if you're worried about it. Somebody linked to, let's quote that into the chat, because we love cat-like coding around here. How do I quote this quote? I want to quote it. There we go. Cat-like coding. Can I link to him? Cat-like coding is on Connect, actually. Cat-like coding is great. He's got a tutorial on curves and splines. Makes great tutorials. Love his work. Highly recommend that you check him out. And he's also on Unity Connect, but I don't know how to link to his Connect profile right now. Yeah, highly recommend his stuff, especially for more like advanced text-based controllers. The PID controller, yes, is working on the lift of the ship. That's correct. Abdullah is asking, could Unity make a built-in post-processing stack for mobile devices? The post-processing stack we have now is compatible with mobile devices. It's not so much the post-processing stack, it's certain expensive GPU operations, right? That's where you're going to run up the cost. It's not so much the implementation, it's the operations, right? Certain operations, a mobile GPU is just not powerful enough to do at the speed that you want. Somebody's asking whether that is $100,000 netto or brutto, meaning net or revenue. I believe it's revenue, but revenue before any deductions, so just the amount of money that you're taking in. But please read the EULA to find that out, because I'm not a lawyer, nor am I a EULA expert. I know it's $100,000 is the target, and if you're somewhere around there and you're not sure, you probably need to buy a license, right? If you're already making that money with Unity, we would strongly encourage you in the friendliest way to please buy a license and support the work that we do. Yeah, as Dylan says, yeah, it's 100K net. Yep. Excuse me while I drink some water. Okay, so I'm going to bring this one in for a landing. Thank you guys so much for coming out. It's always such a super pleasure to see you. Thanks again to Mike Cook for joining us. We will be back here tomorrow night at 8 p.m. GMT. My name is Matt Schell. I'm an online evangelist at Unity Technologies. Thanks again to Mike Geig, who's also a member of the evangelism team at Unity focusing on content and who is one of the two trainers in this video. Thanks for joining in the chat and answering questions, and thanks so much to all of you for being here with us tonight. So I'm going to cut the stream. We'll leave the chat running so we can keep the discussion rolling. And thanks again for watching. The videos actually should be up on YouTube by now if you want to go look for those. Maybe I can link them in the chat as well. So thanks so much, everybody, and see you tomorrow.